Good morning, good afternoon, good evening, whatever time you're watching this. Hello, welcome to my session for the Leeds Maths Conference 2020. This session is called Doing the Right Stuff. It is a session that I've delivered at the SLDM at LaSalle Education's Maths Conference 22 in Manchester, at Maths Conference 24 online. And is a session about doing the right thing for students at the right time for their mathematical ability. The resources that I talk about in this session are available to download at taylorda01.weebly.com, and I am available on Twitter at taylorda01. For any questions that you might have that come out of this, my name is Dave Taylor. This is my 13th year of teaching. This is my 11th year in my current school, and I am currently Assistant Curriculum Leader at Mount St Mary's Catholic High School. For context, Mount St Mary's Catholic High School is a school in LS9 with approximately 50% of our students qualifying for the Pupil Premium. They're 50% disadvantaged. And in 2019, our results were about 11% 7 plus, 40% 5 plus, 66% 4 plus, and about 99.5% 1 plus, with only one student dropping through the net, achieving a U. And in my last 13 years, these results have increased markedly, and so has everything that we do. Everything that we do has improved massively at Mount St Mary's. There's been times that my teaching's looked a little bit like this, whack-a-mole. So a mole whacks up and then you hit it and then you deal with problems as they arrive, whereas most of my days look a little bit more like this now. And a lot of this comes down to the CPD that I've undertaken, which I'll go on to talk about. But before the CPD, I used to walk around school and I'd be like, "You're giving me advice? I know what I'm doing. I get very good results. Students in my class experience success." I've been on a number of CPD days where I began to question my practice a lot, and I was asking questions like, cognitive what now? The hyper what effect? And what do you mean far transfer? What's that? And since I've done that CPD, I'm continually looking to improve my practice. On a daily basis, it looks a little bit like this. I'm a bit obsessive over it, and I question everything that I'm doing. The beginning of this journey on CPD led me to create a suite of resources, a number of worksheets called Increasingly Difficult Questions. They are available to download at taylorda01.weebly.com. And I want to spend the first couple of slides of this section going through where this came out of. So in 2016, a number of teachers went to Shanghai. They fed back their findings, and the bit that grabbed me sparked a conversation at Maths Conf 7 in June 2016, where we talked about textbooks and how English textbooks are 20 questions of the same thing. But Shanghai textbooks, they ramp up the difficulty fairly quickly. My interpretation would be a diagram like this, where the level of difficulty in English textbooks might get harder, but not that much harder, and it'll be one step, and then it'll be the same questions for the second half. Whereas the Shanghai textbooks have a couple of questions at the same difficulty level, and then ramp that up. This is at a lower level of difficulty. The higher level of difficulty might look more like this. And the conversation was, someone should create these resources, and me being the childless adult that I was, kind of went, someone should create these, and I quickly realised that maybe that's going to be me. So I met with my department, we discussed what these activities might look like. We started to write a couple together collaboratively. What this looked like was I'd just grab a sheet, I'd write question 1 on it, I'd stick it on the board in the workroom, and ask staff just to add what would come next. Only write one question, and then somebody else writes the next one, and somebody else writes the next one, so that we're trying to increase difficulty all the time. And then I'd create them into, I'd type them up, something that looked prettier, I guess, My aims upon creating these and putting together the work from the department was I want it to be easy to incorporate into existing practice. I wanted it free of clutter, so no pictures of Homer Simpson or Bart Simpson jumping in. I wanted it cheap to photocopy. I'm aware of how budgets are looking and have done for the last few years. I wanted a low floor and a high ceiling. I wanted kids to experience success as soon as they started these activities, but I wanted the higher achieving students, the higher attaining students to experience some challenging questions. And I wanted that extension to go beyond their expectations of themselves and my expectations of them. They are available to download from this page, which is the page that you get when you click Increasing Difficult Questions at the top on taylorda01.weebly.com. The resources themselves were announced as Resourceaholic.com's best new resources, which was actually ahead of EdXL's materials to support the new GCSE at the time. And in February 2020, Craig Barton released his book Reflect, Expect, Check, Explain, which announced me as the Master of Fluency Practice, which, whilst I maybe don't agree, is very flattering to read. And I just thought I'd spend the next 5 slides taking you through my thought process in creating some of these activities, the first of which is my expanding brackets one. This starts with a nice positive term in the brackets, and then a negative term in the brackets. Let's go for a positive term with a coefficient of y, and then let's have a negative term with a coefficient of n. If kids can expand these, they can definitely expand 3 terms next. And then let's introduce some squared terms through multiplying, a negative term with a squared term. Where the resultant terms may be multiplicative, let's introduce some of that. And then I've got 2 constants to multiply as part of my multiplicative. In this one, all terms are multiplicative. And then if students have got to that stage, they can almost definitely find the sum of 2 brackets, or the difference between 2 brackets. And I thought that was a nice extension for an expanding brackets activity before you go on to finding the sum of 2 brackets with your entire class. Your higher attainers are already there and you're pushing them up to that point already. Out of the conversation at Maths Conf 7, what came out of that was, if we're trying to write these kind of questions, let's introduce some negatives, let's put some decimals in there, let's try and introduce algebra wherever we can, so that kids have been challenged and they're having to think about things that they might ordinarily find quite challenging at all times. Simplifying ratios was the next one that I wanted to move into. The first 7 questions are just straightforward, going through the 2s, 5s, 10s, 3, 11s, 4 and 12 times tables. And if students have got to that point, they can definitely simplify a ratio with 3 terms. And then let's extend them. Let's think about different units. I think that these give a nice opportunity to discuss the idea of comparing things and how they need to be in the same units for us to do that. And then let's extend them further by using algebra. Unfortunately, I couldn't get much in terms of negatives or decimals into here, although I and L do have some decimals. The next one that I wanted to go on to was factorising quadratics. Now, I showed the entirety of it this time just to talk through. So I've got 1 choice for my values to go in the brackets in A. I've got more than 1 choice in B. And by the time I've come to C, I've got 2 choices, only 2 choices, because I've introduced a negative. And in D, I've still got my negative, but I've got greater than 2 choices. In E, I want students to start to develop the idea that they can write this as a square, not x minus 3, but x minus 3 squared. In F, I want to introduce a prime coefficient and only 1 choice for my factors of C. And in G, a prime coefficient and greater than 1 choice for my factors of C to get kids thinking. In H, I want them to understand that they can divide the whole thing by 2 before they can start factorising. And if they don't divide by 2, then there will be the opportunity for multiple answers in terms of the brackets that they get, but one of their brackets will always have a factor of 2 that they can take out and should take out. By the time we get to I, I've got multiple factors for A and C. In J, I'm introducing the difference of two squares, and in K, it's divisible, and it's the difference of two squares. And by the time we get to L, our higher attending students are factorising simple cubics, which I really like, and it gives students a bit of a buzz knowing that they factorise a cubic and that they don't necessarily have to do that as part of their GCSE. The next activity I chose was fractions of shapes. I've chosen this one from a personal perspective because I really like doing this with students. It's really nice to see if the students get the idea that D is a half, even though it doesn't look like a half at first. But if you can pick those bits up and put them in the white bits on the left, then it does give me a half. I like questions E and G. E, students normally give me the answer of an eighth, and then I can try and point out that the answer is actually a tenth. And in G, students normally give a third as an answer. And at this point, I can prompt them to say, well, the two shaded bits, they're not actually the same size, are they? Could you break that into smaller bits where they are the same size? At which point, students normally do get to the correct answer of 5/8, and that helps them moving on into I, J, and K, and then L, they draw their own lines on. And I do like this activity. It's one of my favourites to run through with students. And the last one was, I think a choice that was maybe forced upon myself by me, but having heard and read Ollie Lovell's words, who says that this is the best worksheet he's ever seen for perimeter. I'm quite proud of this one and felt like I should share this one as well. What I'm going to talk about now is how I've used them. So my main use of these was to give students a set of questions, have them work through them, find the level that they get to, where they start experiencing difficulty. Stop my class, run through all the answers as far as I need to. Show students how to do each of the questions up to a particular point. And then say, right, now that I've run through this, I want you to start at the point that you found most challenging, and work through these ones. Same questions, different numbers, just to prove to yourself that you now do know more than what you did when you came in. That was my main use of them, as well as just using them as a replacement for a standard textbook exercise. But at Maths Conference 22, I asked delegates to share their potential uses. The answers, the responses that came out of that question were as a diagnostic tool to ascertain a starting point for my class, so that I'm not teaching them stuff that they're already good at. That just seems like a waste of time, particularly when we maybe feel like we don't get enough time with them. I've never used them as an end of unit assessment, but I do see their use there, or as a mid-topic assessment. So the diagnosis doesn't just happen at the beginning; it happens halfway through. So where do I go next? How do I plan my instruction and my activities best for the rest of the time that we're going to spend on this topic? To build up fluency before segueing into problem solving, because the majority of the exercises are heavily focused on AO1, and that can underpin what comes next in terms of AO2 and AO3. Discussing the differences between questions to deepen understanding is a great conversation to have with students. Why do you think question D is more difficult than C? What's the same and what's different? So what makes it more challenging? And what makes it quite easily attainable when you compare it back to C, which is a great thing for kids to talk about, so that they do deepen their understanding of ideas. To identify specific areas difficult for different students. So for students having difficulty on C, I can write a couple of questions in their exercise book so that they can show me that they have understood the explanation that I've given them on C before they move on to D, and therefore that extra practice on C should help them. And also freeze differentiation. They're not just grouped by lower, middle, and higher. And I know that a lot of students just go, I'm going to do the hard ones because that makes me feel good about myself. But some students do have different needs in different topics. And as a result, there is no gold column that they always want to work towards. There is no sum. I want to be some of the sum. There is no almost and some. There is no low, middle, higher. There is just an opportunity for students to progress through a set of questions in an exercise and show their strengths and highlight their areas for development so that can be worked on. At the same session, Maths Conference 22 in Manchester, I also asked for the benefits of diagnostic questions. They came out that they are easy to use, they are low printing costs, they're inspirational for students with high levels of challenge, they are not repetitive. So going back to those first diagrams, they ramp up in challenge quickly. Easy differentiation and a diagnostic tool, which were the potential uses we discussed. Develop depth of understanding again, and good purposeful practice to focus in on a specific need. And my own outcomes that I found from this, students bought in more to what they were doing. They weren't finding things too hard straight away. They were experiencing some success early on in their work, and this meant that they were more motivated. And that, I think, that came out with their results with their GCSE results that came out with. Not only were they more motivated in lessons, they were actually more motivated to work externally as well, having felt some success. Now, in 2017, my daughter was born, and what that meant was inclusive and difficult questions took a bit of a back foot. So the PDFs that are available on the website, there have been limited alterations to those since 2017. There have been very few additions, and anything that I have worked on has been my e-textbook. Now, you may not have seen this, it's hidden. It is hidden here, where it says a sample is available here, and any feedback is absolutely welcome. It is an Excel file that you will need to download, and if you press F9 on particular sheets, it will randomize the values. Now, my favourite way to use that was to throw it up on the board, have students work through it in the same way that they were just before, stop them after even a short amount of time, run through the answers to everything that was part of that exercise, show students how to do them, and then press F9. That puts some new questions up there. Where you had difficulty, that's where you start. And I could do that 2 or 3 times so that students are really, really, really developing confidence, success. They're experiencing a lot of success, and it's increasing their motivation, so they're more likely to work outside the classroom for me as a classroom teacher. Now, in the last 3 years, since my daughter was born, I've taken a bit of a route into middle leadership. And so the next slides that I'll run through will talk about what I've done as a middle leader in the department at Mount St Mary's. So previous to the changes that I have made that I'll go on to talk about, we were kind of operating a conveyor belt scheme of learning. It's something that I was used to. I trained in it. I developed in that kind of system of education, where students just do different objectives because they're at a different age, which seems a little bit mad to me, having gone through some of the CPD that I have and some of the reading that I've done. And I found myself in the position of an intern on a TV show called Scrubs, where an intern asked Dr. Cox, what's the correct dosage? And Cox's response is, well, you open their mouth, you take a handful of pills, and you throw them. And then whatever sticks, that's the correct dosage. And I felt that in the conveyor belt system education, that's where I was a little bit. I looked at what I was being told to do by my head of department on the scheme of learning, and I just did my best. I chucked at them what I could, and then whatever stuck, and whatever didn't, I'd done my bit where I was hamstrung. I was able to combat that using increasing difficult questions, and also coming across Dan Mayer's 3-act math tasks. If you Google Dan Mayer math, you'll come across his website. And the questions that he was asking were things like, if this is the headache, then what is the aspirin? If this is what is challenging students, how can I improve what I'm doing, what I'm giving them, such that their experiences in the classroom get better? And so I'm going to run through a couple of case studies as to how I think about this, what my interpretation of the reading and the CPD that I've done is, with a couple of case studies. First of which is a young lady called Janet. Janet is an all-knowing being. In Key Stage 2, she has a scale of 113. And from that, we can glean that Janet's probably a confident young mathematician who, in her 6 years at primary school, has experienced a lot of success. She gets stuff right all the time, and a teacher congratulates her all the time. Into year 7, and she'll do in week 1 the M7 of sequence, because that makes sense. That's what she'll do. You can find a scheme of learning on the internet that will mean that you will do M7 of sequence in week 1. Now, having a scale score of 113 means that Janet scored 102 or 103 out of 110. Now that must be great, walking out of a test knowing that you've scored 102 or 103 out of 110. You've enjoyed that test. You've experienced success on that test. Now the second case study would be Eleanor. Eleanor is a little bit less all-knowing. Eleanor has a scale score of 82. And going back to those tables, that means that Eleanor scored about 7 or 8 marks out of 110. It's probably safe to assume that Eleanor lacks success in her maths lessons. And she's probably unlikely to know her times tables off by heart. And then in year 7, week 1, she studies the M10 of a sequence. And I don't think that is the right time for Eleanor to be studying the M10 of a sequence, particularly if she can't recognise sequences of times tables as a bare minimum. And this idea takes me back to a tweet from Mark McCall, who tweeted saying that at the age of 11, a typical year group contains pupils spanning around 7 years worth of learning. And what happens if you give them all the same content? And there's some fruity language just to warn you. Well, this happens. Your top end are bored. Your bottom end are finding it too hard. And how many students out of a class of 28 are appropriately challenged? 6, maybe 7. That means that 22, 21, they're not appropriately challenged. And where they're finding this way too hard or a little bit boring, they're going to find something else to do. And the only thing that they can do in that classroom is mess about with their mates. And so you find behaviour takes a big hit. Mark wrote a book called Teaching for Mastery, which if you haven't invested in the book, I suggest that you do, and you invest heavily in the time to sit down and read it. I think I've now read it twice. I nod along to every page. And for me, the mastery model of teaching, that is replicating personal tuition for a whole class, has to be the way forward. I mean, I couldn't imagine a personal tutor taking on, let's say, a year 9 student and saying, well, I'll contact your school and I'll see what the scheme of learning says, and then saying, well, you're year 9 now, so we're going to look at Pythagoras, when that student has no idea what squaring numbers is. I think that's a hiding to nothing. And so a personal tutor wouldn't do that. So why, as a classroom teacher, would I do that just because it says it on a scheme of learning? Complete Mathematics is a company that Mark is the head of, and they offer CPD and an online platform where you can use a mastery scheme of learning straight out of the packet. Now I understand that circumstance and content and context dictate the needs of a department, and whilst Complete Maths, I'd highly recommend it straight out of the bag. I've actually used Complete Maths to go a different route that I'm gonna talk through now. I'm calling it Maths meets Modular Assessment, and our scheme of learning looks a little bit like this, where students work through 5 modules, and in Year 7 they begin their journey from one of 4 different starting points. Now those 4 starting points are here. Now this is more legible. The previous slide, definitely not legible. There is a link on my Twitter page at TaylorDA01 to download the dartboard as an image. It's 100 megabytes, so it's quite large. There's a lot of information on there, but it means that you can zoom in and read the topics that students are covering. What this means is that our students don't start from the same point when they come in Year 7. Our lowest attaining students, we don't do coordinates in all 4 quadrants straight away with them. We look at coordinates in the first quadrant because they're unlikely to be able to use negative numbers properly without that having an adverse effect. We don't start with for the mean average, for example, with every student, because if students are unable to divide, then asking them to calculate the mean average means that they're not having difficulty with the mean average. If they're finding it hard, they're having difficulty dividing, and that's a totally different problem. Now this has been in place for 2 years, and having looked at our internal tracking data, having looked at our behaviour data from the whole school systems that we employ, I've found that after 2 years we're getting more buy-in from students. We're getting more success from students, and students are more motivated to work hard in our lessons. Students behave better in our lessons under this model. And what was raised to me a couple of weeks ago from a geography teacher was that students enjoy their lessons more. They're enjoying their maths lessons more because they're experiencing that success. So they're motivated to work hard, and they're finding that enjoyable. In terms of the motivation, that's where I'm going to go on to now. Motivation, I think, underpins a lot of what we do. So I'm going to go through 2 more students as case studies. This is Chidi. Chidi was in my Year 10 bottom set, and Chidi, at the end of Year 10, had a mock score of 14 out of 160. Now that means that Chidi did 2 papers and scored single figures on both. And that feedback was quite hard. It was quite hard for me to give, but also the response from him was quite hard to take because he just laughed about it. And I guess that's one of the only options that he's got. He's either got to laugh or cry. And no one wants to see a 14, 15-year-old boy cry. So what I started to do with my Year 10 bottom set was, we started the AQA entry level certificate. Now, Chidi's got 198 out of 240 on that. Where his old normal was getting single figures on a paper, his new normal was getting more than 25 on a paper. And that was a really, really positive thing for us. A really, really positive thing for him. He experienced more success. And at the end of Year 11, scored 60 out of 240. And that's an increase from a score of less than 10% to 25% in a year, which will take him from a U to a 2. And we don't necessarily enter students for the entry level certificate, but I think that there's a lot of weight behind doing it with them, just to normalise success, to normalise being able to do things in a maths test. And if you do that for 3 months and you do a test every 2 weeks, and then you say, right, this test that you've done, I want you to now improve it, the kids feel that they can, which means that the next time that you give them a test, they're more willing to try, they're more willing to write things down. My second case study is a young man called Michael. Michael had a Key Stage 2 score of 4.5. And in their Year 10 mock, they scored 72 out of 180. Now, suppose these are 3 papers of 60 marks. That's 24 marks on each one. That's not too bad. That's not too bad. But then, we do a Year 11 mock, and they get 20 out of 161. We've adapted a higher paper. And that is crushing, because that's a U. And that student had never achieved a U in their life. And the problem that we have is that Michael can do maths. But they can do maths when they've had a bit of a running jump. They could do question 5 on the higher paper, but they could do question 5 on the higher paper when it was question 28 on the foundation paper, because they've gone through 27 questions where they've developed confidence and felt success. They needed the warm-up that foundation gave them. And ultimately, Michael got a 5 at GCSE. Now, maybe the response is that at the stage that Michael gets 20 out of 161, I might have a chat about their mindset. And I know that Michael's gone through an assembly on growth mindset. Seen a few posters around school, and they're expected to bounce back because, come on, have a growth mindset. And that implies that this exists, that if you can motivate someone, they'll succeed. And if you've ever listened to the Mr. Barton Math podcast with Craig Barton, he talks about a student who comes out of a growth mindset assembly straight into his classroom, and then he says, oh, come on, we need to have a growth mindset. And the student says, yeah, but sir, it's a bit hard to have a growth mindset when you keep doing shit in tests. And that kid has a really, really valid point. Maybe they've got a growth mindset lesson that's timetabled. That's 1 lesson out of 50, where everyone's at the same starting point, where they might learn to count to 10 in Japanese, or they might learn to juggle, where they're all at the same starting point, before they then spend 49 lessons out of 15 bottom sets experiencing no success. And then they go back into that one every fortnight, and they're told to have a growth mindset, and they just can't, because they're not experiencing the success that they need. Shortly after I delivered this at the SLDM, Chris McGrain tweeted this, which is a quote from Gusky, who is a proponent of the mastery scheme as a learning, the mastery model of education. And I think that there's a bit that's really important here. Change student experiences so that they can develop a growth mindset for themselves. And growth mindset can't just be an assembly and then stick some posters up around school. It has to become a culture in what you do entirely around school. Because if you are working with your lowest attainers, and we're not working to their strengths and building on those strengths, and they're just being put through a conveyor belt curriculum whereby they're experiencing no success, they cannot be expected to have a growth mindset. This is the cycle that we need. We need students to experience success to develop their motivation. Now, for Michael, that was the entry level. No, for Michael, that was doing foundation GCSE. For Chidi, that was the entry level. They experienced some success, and as a result, they would become more motivated, which meant that they worked harder, so they experienced more success, which meant they became more motivated and experienced more success and became more motivated. And it's our job as educators to put students in this virtuous cycle of success feeding motivation, which in turn feeds more success. So I've used my interpretation of teaching for mastery and utilised the curriculum on complete mathematics to develop our curriculum here. which is a journey throughout mathematics, building on success in a spiral. And as students are on their way out, they're revisiting things all the way through. They're revisiting ideas and they're embedding those ideas, and then they're developing on those ideas. And this is a journey where the innermost ring is in line with the Year 3 curriculum, because that is what I believe our lowest attainers need. But the outer ring goes towards Level 2 Further Maths, the additional qualification offered by AQA. And as a list, it kind of looks like this. We've got 9 units in each of 5 modules, where Module 1 is Year 3. Module 3 is in line with Year 6. The higher and foundation split happens at about Unit 7. And Level 2 Further Maths should be mastered by the end of Unit 9. And if we take a random Year 9 student, for example, if a random Year 9 student has had success at Unit 5 last year, that is the point at which our teaching starts the next year. Each student is taught from the level that they've had success at last year, so that we can teach them just beyond their current level of understanding, so that they can assimilate those ideas much more easily. And then those students are assessed. So of those 9 units, I create 9 assessments of 20 marks, and those 9 assessments of 20 marks form 7 assessments of 60 marks. And the students are assessed across 3 units. They're assessed on the level that they had success with last year, because this is the bit where they will sit down in the test and experience positivity by getting things right. The one that we've been working towards as a main focus for this year, they'll be assessed on that unit as well. And then there's the opportunity for extension, because the scheme of learning is designed to go just beyond what they currently know. It means that there is a chance for students to progress at a faster rate. Now, on these assessments, I expect students to score 15 marks on the first bit, because human error, kids make mistakes. 10 marks on the second bit and 5 marks on the last bit, because there is the opportunity to test your ideas out that you've got on harder content. And anyone who achieves more than 50% is rewarded and celebrated, because I think that's really important. I think 50% is really important because of the grade boundaries at GCSE. About 50% gives you a grade 4 on foundation and a grade 7 on higher. Expecting students to get about 50% normalises challenge, but also normalises resilience. If they've experienced a test where potentially they find the last third quite hard, and if they've done that 20 times throughout years 7, 8, 9 and 10, it means that by the time they've come to year 11 and they sit a GCSE paper as a mock, as a practice paper, as anything, they've developed the idea of resilience from early on, and they can build from that. But it also shows from a mathematics point of view that there's always something new to learn. There's always something extra coming afterwards. So our GCSE goes into level 2 further maths, level 2 further maths goes into the A level, the A level goes into further maths at A level, and so on and so forth. Now, in theory, what this means for us is our students that come in with a scale score of between 90 and 100, they progress to the foundation and higher split. In theory, they will have had success on our stuff in Unit 2, and we'll teach them Unit 3, and then we'll assess them at Unit 4 as an extension opportunity. And then next year, we'll start at Unit 3 where they've achieved some success, push them onto Unit 4 that they've experienced last year in their assessment, and then extend them to 5, and then in Year 9 they get pushed. By the time they get to Year 11, we're looking at objectives from the higher foundation split and from the higher GCSE for our students that have a scale score of 90 to 100. Our 110 pluses, maybe 107 pluses it may end up being, they start at a higher point, and they'll be assessed at 4, 5, 6 in year 7, at 5, 6, 7 in year 8, at 6, 7, 8 in year 9, at 7, 8, 9 in year 10. And by the time they're into year 11, they're mastering level 2 further maths content, they're mastering matrices and transformations expressed as matrices. Now, practically speaking, stagnation may occur. Kids might not make that 1 unit leap across every module every year, but it means that the students are just taking longer to develop those ideas. So the students might repeat a unit rather than just move on because they're a year older, and repeating that unit means that they're learning just beyond their current level of understanding to develop that understanding before they can then push on further, because students with a greater grounding in mathematics can learn at pace and can learn at pace and can go beyond their own expectations. And I really hope that that's come across with what we're doing at Mount St Mary's. Now this is the end of my presentation, so I just want to say thank you for watching and listening to my rambling. Sitting here in an empty living room talking to myself isn't an easy thing to do. And normally at the conference we'd have the opportunity for questions. That's been taken away from us due to the current circumstances. So if you have any questions, please direct those to me via Twitter. But also have a great day. And thank you for your time.